Hi everyone and welcome back with Physics with Mr. Simons, right, where we simplify physics and we get you exam ready. Right, so we're looking again at grade 11 electromagnetism. In today's lesson we're looking at grade 11 November 2017. And now in this variation we're testing you via graph. Can you calculate change in magnetic flux using a graph? Right, so without further ado, let's look at a question. So question 9, induction coil of area 48.6 centimeters squared and 200 windings is rotated clockwise in a constant magnetic field of magnitude 2.4 Tesla. Refer to the diagram below. So they say this area here that it's rotating through is 48.6. Around this coil we have 200 turns or 200 windings. And the strength from north to south, and as you can see magnetic field always goes from north to south, is 2.4 Tesla. Right, now they say the graph below shows how the induced EMF varies with the inverse of time. So at 0 seconds we had 0 EMF or induced EMF. At 1 we were somewhere there, let's see, 1.2, 1.4, 1.6. At 2, at 3, etc. Right, so the graph shows how when time went on, or 1 over change in time, and how the graph or the voltage increased. So 9.1, state Faraday's laws in words for 2 marks. By now you should see that question is always tested. 2 marks if you study your definitions. Use the information in the graph to calculate the change in magnetic flux for 5 marks. 9.3, the coil is rotated through an angle theta to a position where the magnetic flux becomes 0. Calculate angle theta for 4 marks. So you can pause here, see what you can answer. Right, I'm going to solutions now. 9.1, this is state Faraday's laws in words, or Faraday's law in words. So number 1, the magnitude of the induced EMF across the ends of the conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. 2 marks. Right, so in short, if you study your definitions and you know your definitions, you can basically pass physics in grade 11 or grade 12. They make sure there's 30% and more, although I don't agree with the pass rate of 30%. Should be more 50%, but yeah, I don't make the rules. 9.2, use the information of the graph to calculate the change in magnetic flux. So according to the graph, right, see there my equation, EMF equal negative N, change in magnetic flux over change in T, right? So N was given to me as 200 windings. So I need a EMF and I need a change in or induced EMF and change in time. So from the graph you see I have EMF and I have change in time, or 1 over change in time, just same as there on top. Remember, 1 over change in time. So if I go here at 1,8 and 3, take note I can choose any point. I could have gone here at 0,2, 0,4, 0,6 and 1 and use those 2 as well. Alright, I just might choose 1,8 and 3. So there EMF equal 3 minus N negative 200, change in magnetic flux or change in phi, which I'm looking for, and 1 over change in T, which is 1,8. So 1 mark correct formula, 1 for correctly substituting my EMF, 1 for substituting my number of windings, 1 for correctly substituting 1,8. If I simplify that all, my change in magnetic flux equals 0,0083 Weber. Alright, so I hope you follow. So you see there, I can work from a graph as well, right, to work out change in magnetic flux. Alright, let's look at the next problem. Alright, now 9.3, they say the coil is rotated through an angle theta to a position where the magnetic flux becomes 0. Calculate angle theta for 4 marks. Right, so it's rotated, so we have a change in magnetic flux, which equal my final magnetic flux minus my initial magnetic flux. So we just calculated the change in magnetic flux as 0,0083 Weber. Right, so my final became 0, so 0 cos 90 is 0, and 0 times anything stays 0, so there that would stay. 4,86 times 10 to the negative 3 times the magnetic field strength of 2,4. Right, and on this side here, minus 4,86, 2,4 times the cos of 0. So we've gone from 0 to what it was initially. Alright, that there is 0, so that would be negative 0,083 divided by negative 4,86 times 10 to the negative 3 times 2,4 cos theta. Then I'm going to say shift cos, that punch in that value, equal on my calculator, and theta equal 44,64 degrees. So 1 mark for understanding from the previous question, change in magnetic flux. There, understanding that it's B times A, so magnetic field times area. Alright, and then understanding to make magnetic flux 0, cos 90. Alright, so cos 90 there to make magnetic flux 0. So my final was 0. It's rotated to position where it becomes 0. So to get to 0, we just change to cos 90, because 0 times anything stays 0. Right? Wish you all the best. Continue practicing. God bless. Bye. Have a wonderful day. God bless.